In this demo, we'll start using HTTP Client Factory. The first thing we'll need to do is add the NuGet package where HTTP Client Factory is defined in. Let's open the NuGet dialog. What we're looking for is the Microsoft.extensions.http package. Let's click Install. And there we go. If you're using ASP.NET Core, you don't need to do this, as this package is already referenced by the Microsoft.ASP.NET Core meta package. Now we need to register the required services on the container and configure our HTTP client instances. We do that by calling add HTTP client on the service collection in the configure services method. For now, that's where we'll stop, but we'll revisit this soon. And let's open our service. To actually get a new instance, we need the factory. So let's inject that factory via constructor injection. There we go. So far so good. Now let's add a new method to get our movies. We name it getMovies with HTTP client from factory, and it accepts a cancellation token. We don't use a static variable for HTTP client this time. We create a new HTTP client by calling createClient on our factory. Next, we create a new request to API/movies and we read out a response, following the best practices we learned about up until now. We just need to import a few namespaces to make this work. All of these are the same as from the previous demos. There we go. Let's put a breakpoint right after we deserialize the list of movies. And let's make sure we call this method. So in our run method, we await a call into getMovies with HTTP client factory. This requires us to pass in a cancellation token, so we pass that through. Alright, let's give that a try. We hit our breakpoint, but let's have a look at that console window. The first thing we notice is that by default the client factory logs information about requests. That can come in quite handy when you're trying to fix potential bugs. Let's go back to our breakpoint. This seems to have worked. Let's have a look at our list of movies. And there we go. This works as expected. Yet, it would be nice to be able to input a few defaults, like the base address. Currently, we have inputted the base address as part of the URI where the movies can be found. Let's have a look at our program class again, where we added the HTTP client on the service collection. There's quite a few overloads for this. For the untyped add HTTP client method, we see that we can input configuration for the client if we register it with a specific name. We can do the same for a typed client. So that sounds like what we need. Let's start with named instances in the next demo. If you're only integrating with one API and you're okay with not using any default settings, you should be good with what we have. But that's not very realistic. Clients can integrate with different APIs or with the same one but with different default settings. Named instances can help with that. They allow us to register a client with a specific name and configuration, which we can then instantiate by name. So let's choose a name, say Movies Client. Then we can pass in an action to configure the defaults for this client. So, just as in our other demos, we set the base address, timeout, and clear the default request headers. Alright, back to our service. Let's copy the method we have, so it's saved for reference later on. And let's rename it to getMovies with named HTTP client from factory. To get our pre-configured named instance, we pass through the name to the createClient method, Movies Client. The client that's now created will have the defaults configured as we just did. So we no longer have to pass through the base address. By the way, if we just call createClient, we'll still get back an instance of HTTP client. So the previous method will still work, but it won't have defaults configured. Let's set a breakpoint right after we got the movies, and let's make sure this method is executed. Alright, let's give this a try. We hit our breakpoint, and here's our movie list. So far, so good. If we look back at our code, there seems to be something missing. Let's open that stream service again. We know that our API supports gzip compression, and previously we enabled that at client level by configuring the HTTP client handler with automatic decompression set to gzip. Let's learn how we can achieve that with an HTTP client factory. Next to configuring our HTTP client, we can also configure the primary handler, i.e. the HTTP client handler, within the configure services method where we registered our named instance. On add HTTP client, we can call configure primary HTTP message handler. This allows us to pass through a function to configure it. So we state that the function should return a new HTTP client handler with automatic decompression set to gzip. That's it for configuration. Let's have a look at the getMovies with named HTTP client from factory method again. As we remember from the previous demos, we can state that we want to accept gzip encoding by adding an accept encoding value of gzip. Our breakpoint is still there from the previous demo, so let's build our run. We hit our breakpoint, and here's our list of movies again. So far, so good. Different strategies now emerge. I sometimes see various named instances to access the same service, which then have default accept headers or accept encoding headers that differ. Personally though, I still prefer to do that on the request message itself, so I would advise to do that. Yet, your mileage may vary. Next to named instances, we can use typed instances. Let's learn about those. Typed instances provide the same capabilities as named instances without the need to use strings as keys. Let's add a new class, Movies Client. That's gonna be our typed instance. So we give it the name Movies Client. In this class we inject an HTTP client with constructor injection, and we make it publicly available as a property with just a getter. We will use this property from our method later on to get to the actual HTTP client. We'll of course have to add a using statement to system.net.http. What we want to do next is register this movies client on the service collection. So let's open the program class again in the configure services method. We call add HTTP client, passing through movies client as the type. This registers our movies client with a transient scope. The factory will automatically create an instance of HTTP client with whichever configuration we input when an instance of movies client is requested from the DI system. So just as before, we want to add some default configuration. It's the exact same configuration we used for our named client. We set the base address and timeout value, and we clear the default request headers. Next to that, we configure the primary HTTP message handler so it supports automatic gzip decompression. That's it for registration and configuration. On to our service. Here we can now inject a movies client instance via constructor injection. Now let's add a field to store that in. There we go. It's this instance we can use to access our API. Let's scroll down a bit. And let's copy that getMovies with named HTTP client from factory method, so we still have it for reference later on. And we rename this to getMovies with typed HTTP client from factory. We no longer need to create a client through the HTTP client factory, so let's remove that line. We can use the client property on our movies client instance, which is created by the factory, to send the request. Alright, let's put a breakpoint here, right after the movies have been deserialized. And let's make sure we call this method. There we go. Let's give this a try. We hit our breakpoint. And there's our list of movies. So far, so good. There's more we can do though. We can scope the configuration to our type instead of on configuration in the program class. Let's learn how we can do that. We're looking at our movies client. As the dependency injection system injects an HTTP client instance, we can move the default configuration to the constructor. So we set the base address, we set a timeout value, and we clear the default request headers. What we don't want to do here is override the configured client handler. If we do that, it won't be coming from the pool anymore, and we don't want that. Let's open the configure services method and change our configuration. Let's comment now to one from the previous demo. And let's add some new configuration. We call add HTTP client, passing through movies client as type. What we don't pass through is a method to configure that movies client, as we're now doing that in the movies client constructor. We do still configure the primary HTTP message handler, so it supports gzip decompression. Let's give that a try. We hit our breakpoint, and here's our list with movies again. So far, so good. Let's have a look at movies client. This does look quite empty, doesn't it? Let's see what else we can do to improve this.